we are gathered here to know about the methods of measurement of elasticity of demand. We all know that elasticity of demand is most important tool of economic analysis, both in microeconomics and in macroeconomics. Here we are concentrating on the tool as measurement. Elasticity of demand, we all have read at different stages that elasticity of demand is equal to marginal by average. Marginal by average. Marginal demand by average demand. That means dy by dx by y by x. That is known as elasticity of demand. As we see in the diagram, that elasticity of demand is equal to marginal demand by average demand. Marginal demand is delta D by delta P, average demand D by P. Delta D by delta P, P by D, minus. This is elasticity of demand. This is elasticity. In calculus, elasticity of demand will be equal to minus dd by dp, p by d. Elasticity of demand is defined as rate of change in demand as price change. Here we are concentrating on the methods of measurement of elasticity of demand. There are 4 methods of measurement of elasticity of demand. Number 1 is percentage method. Number 2 is total outlay method. Number 3 is point method, point elasticity method. Number 4 is cross elasticity of method. These are the 4 methods which are important and which are used as per the requirement and as per the availability of data related to price, related to total outlay, related to demand curve. In that way we can calculate elasticity of demand. First method is percentage method. Percentage method is very popular method to measure elasticity of demand. What is the percentage method? Price elasticity of demand is equal to percentage change in demand by percentage change in price. If both are same, elasticity will be 1. If both are 10%, elasticity will be 10 upon 10 equal to 1. If percentage change in demand is greater than percentage change in price, then this is elasticity more than 1. When percentage change in demand is less than percentage change in price, that will be elasticity less than 1. So elasticity is exactly calculated in terms of absolute number, in terms of figure, that is percentage method of measurement of elasticity of demand. This is a very simple method. John Robinson frequently use this method. The second method is popularly known as total outlay method of measurement of elasticity of demand. Total outlay is just another term for expenditure. When you propose for expenditure, then it is called total outlay. As in budget we always write total outlay, because budget is future 12 months. Likewise, when it is spent, that is elasticity, that is expenditure. So in this case, see on the total outlay method, Here the first is price, second is total expenditure, third is elasticity, fourth is nature of goods. If price falls, total expenditure falls. If price rises, total expenditure, if price falls, total expenditure increases. And this is called elasticity greater than 1. Commodity luxury goods. If price rises, total outlay decreases, elasticity is more than 1, this is luxury goods. It means if there is inverse relationship between price and total outlay, this is the signal that elasticity of demand is greater than 1. And nature of goods will be luxury goods. Second case is price falls, total expenditure falls. Price rises, total expenditure rises. This is called elasticity less than 1. Elasticity less than 1 means necessary goods. These two are very practical things, and we can get more than less than 1. Third one is price falls, total outlay constant. Elasticity of demand equal to 1. Price rises, elasticity of demand is constant. Elasticity of demand equal to 1. This is imaginary goods. Any goods you can keep in which consumer is determined to spend fixed quantity. The expenditure remains constant. This is deliberately done by any consumer for any commodity. Therefore, I have written here imaginary example you can put for that. So, what is the difference between two? Here we can get exact. Here we can get exact elasticity equal to 1. Here we can get exact elasticity equal to 1. Here we can get exact elasticity equal to 2. But here we can get only more than 1 or less than 1 or equal to 1. So here we can get the exact number. So therefore percentage method is used in most of the research work, in most of the calculation work, because this gives the exact number of elasticity of the commodity on which we are spending money in the market. But in the total outlay method we have, if there is no such type of data, we have data of only expenditure and price, then we will use this method. This method is popularized by Alfred Marshall. In 1890. He said that if we have total expenditure data, if we have price data of the market, if there is inverse relationship between price and total expenditure, then elasticity will be more than 1. This will be luxury goods. In the second case, if there is direct relationship, price falls, total outlay falls. Price rises, total outlay rises. Elasticity of demand will be less than 1. This is inelastic and this is necessary goods. So with this method, we can easily find out less than 1, more than 1. Luxury goods, necessary goods. And third one, that there is no variation in the total outlay, whether price rises or falls. This is a specific case. This may be imaginary case. This may be a deliberate decision of the buyer to keep public expenditure constant irrespective of change in price. So this is called elasticity equal to 1. That is imaginary example. Third one is very, very important. This is called geographical method. This is called geographical method of measurement of elasticity of demand. If we have DD curve is, suppose this is demand curve. This is hyperbola demand curve. Here elasticity is always equal to 1. Why? We draw a straight line from A to B, which is tangent at P. This is the lower segment, this is the upper segment, and formula elasticity of demand at P will be equal to lower segment by upper segment. It means PB by PA. And if we suppose PB is equal to PA, then elasticity of demand will be equal to 1. This type of curve in economics very popular. This demand curve is known as hyperbola demand curve. And hyperbola demand curve elasticity of demand is always equal to 1. Everywhere in objective question, you will have a question. What is the elasticity of hyperbola demand curve?
answer will be 1. Elasticity will be 1. This method is known as geographical method. Geometrical method. Geometrical method. And this is a straight line. This is a straight line. This is a straight line. This is tangent. Tangent at P. This is lower segment. This is upper segment. We divide and we get the velocity. Last one is known as arc velocity. Arc velocity is very famous when there is missing data. This is missing data. Missing data. There is a data from D to A and the B to D. But in the mid time this is missing. This is mid time, this is missing. In the mid time this is missing. Mid time this is missing. This is missing data. In this case, it was said that cross arc velocity can be measured by formula this: Q2 minus Q1, Q2 plus Q1 divided by P2 minus P1, P2 plus 1. Suppose we take here 10, we take here 20, we take here 5, we take here 10. Then what we will get? 20 minus 10 upon 20 plus 10, 10 minus 5, 10 plus 5. Then the arc elasticity of demand will be calculated. What will happen? 10 upon 30, 5 upon 50. What will happen? 1 by 3, 1 by 3, 3 by 1. This will be 1 by 3 upon 1 by 3. Inverted like this, then we will have cutting this 1. Here arc elasticity of demand equal to 1. So whatever data you will have in this case, that will be discrete data. This is called discrete data. So this is all about the measurement of elasticity of demand.
We conclude here that which one is better measurement of elasticity of demand? Answer will be that depends upon availability of price data, availability of quantity data, availability of expenditure, availability of demand curve, geometrical representation demand curve. Which type of data you have? If you have percentage change in price, percentage change in demand, then you must apply percentage method of measurement of elasticity of demand. That is very simple, very useful, very popular all over the countries of the world, both in industrial sector, in agriculture sector,